Hello everyone, and welcome to the first video in this series here of only two dealing with linear regression and inference for linear regression. So, for the purposes of the AP exam, there are only two subtopics under this, and that is linear regression t-tests and linear regression t-intervals. And essentially, the big idea behind all of this is instead of just using a residual plot to determine whether or not a line is the best fit for our data, we can perform a hypothesis test or compute a confidence interval to determine if we actually have evidence that the slope of this line is non-zero. So while a residual plot will affirm that a line is the best option, we still don't know in that case if there truly is evidence of a correlation between whatever two variables we're looking at. So that's the big idea. Let's jump into some of the specifics here and get moving. So the linear regression t-interval, like I said before this, the point is to determine, like, do we actually have evidence of a correlation? Having no pattern in the residual plot is great, but this is now just one additional stronger piece of evidence to go along with that. And so the formula for this looks like this. Now, one thing we have to remember is that the formula for a linear regression in the context of AP statistics looks like this, where b sub 0 is your y-intercept and b sub 1 is your slope. So the actual formula for your confidence interval is your slope plus or minus the t-critical value times the standard error of your slope. Now again, one thing that's really important here is this standard error comes from that weird computer printout that you will see. You are not expected to be able to calculate the standard error of the slope on the exam. That is not possible. Same thing for the actual slope here. This comes from the printout. The biggest thing to be careful of in these questions is make sure you're looking at the correct row in the printout and that you're looking at the slope and you're not looking at the y-intercept. That's very important. Now, the other important thing here is to get your t-critical value, if you have to find it yourself. Here, instead of having n minus 1 degrees of freedom, we have n minus 2 degrees of freedom. And the reason for that, or at least the way that I like to explain it in a way that helps it make sense to people, is that before, when we had one variable, we lost 1 degree of freedom. Now that we have two variables, you lose 1 for x and you lose 1 for y. So it becomes n minus 2, where n is your number of data points. So if you have 30 ordered pairs, n is 30. So that's some of like the logistics behind it. Now, here's where things get weird, right? The process for doing this is still panic. However, these are all of your assumptions. And if you notice, there's a lot of them, right? We need to make sure we have a true linear relationship, and it says that you can analyze residuals. This is actually copied and pasted from the AP Stats course and exam description. The standard deviation for y does not vary with x. There's an extra comma here accidentally. Pretend that that's not there. And then we need to have a random sample, and then for any particular x value, the y values are normally distributed. This is almost impossible to verify all of these in a given scenario. It would take so much work. So typically what you get is you get the assume all conditions are met. Usually that sentence shows up somewhere in the question. And so let's take a look at an example question. And the example question is actually a multiple choice question because I haven't seen a free response question in a very long time ask you to actually compute a linear regression t-interval. So if we take a look, right, this is about a class project at a large university. She selected a random sample of 12 students, blah, 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 blah. We get the printout. Here's my favorite thing, assuming that the conditions for inference are satisfied. Like I said, that sentence is almost always going to show up and be a part of your problem. Now, which of the following gives the margin of error? Now here, the margin of error would be the t-critical value times the standard error of the slope. One thing that's important about the standard error of the slope, standard error is equal to your standard deviation divided by the square root of n. So when I'm looking at this column of standard error, that's already divided by the square root of 12. I don't need to do it again. And so for this particular one, with a 95% confidence interval, I know the t-critical from looking at the chart is 2.228. This is something that you could look up yourself, whether you want to use inverse t or you want to use the t distribution table. Just make sure you're looking at 10 degrees of freedom in this case. And the standard error of my slope, remember, slope here is always going to be matching whatever your x variable is or your explanatory variable. So it should be 0.228 times 0.745. The full interval would be 2.697 plus or minus that. And very similarly to the confidence intervals for two means or for two proportions, what you're looking for is, does 0 show up in my interval? If 0 is in your interval, you do not have evidence of a linear regression. Right? And I'm actually going to write that here, right? If this contains 0, we have no evidence of a linear regression or no evidence of a correlation. If the interval is entirely negative or entirely positive, then we do have evidence. Now, like I said, this was a multiple choice question. That is my standard error, and so when I go to look at the answer choices, it is the first one. Now, to be careful, when you look at answer choice B, right, it has that divide by the square root of 12, most common wrong answer. Remember that the standard error already has that division. This is the standard error of the y-intercept, and again, same thing for answer choice D, it has the extra divide by the square root of 12. E makes no sense because that's actually your slope, and so I'm not sure why someone would choose that, but obviously there's a reason why, and at least all of these numbers are numbers that are in that table. So the biggest thing in the multiple choice here is be very careful. This is going to be your most common wrong answer. C and D, also very common if you're reading the wrong row. So make sure you pay close attention. So I hope that was helpful, and I'll catch you guys in the next one. Bye, guys.